Hello, and welcome to Beyond the Last Star. Wherever you are right now, whatever kind of day it has been, you made it here. And that is enough. Find a comfortable position. Let your body settle. If you can, turn the lights down low or off completely. Because tonight, we are not staying here. Tonight we are going somewhere most people never think to go. Past the last planet, past the edge of the sun's reach, into the deep and patient dark where the real universe begins. Before we leave though, drop a comment and tell me where in the world you are listening from right now and what time it is there. I read every single one. There is something I love about knowing that people from every corner of this small blue planet are drifting off to the same stars at the same moment. And if this is your first time here, welcome home. Hit subscribe so the next journey finds you. Now, are you ready? Let's go. Your day is done. Whatever it held, the noise, the weight, the unfinished things, you can set it all down now. Tonight we're going somewhere extraordinary. Tonight we go to Saturn. It begins with a ring. Not one ring. Not the simple flat halo you might picture from a childhood drawing. What surrounds Saturn is something so vast, so delicate, and so ancient that even after centuries of watching it through telescopes and cameras and instruments, we have only just begun to understand what we are looking at. The rings of Saturn stretch outward from the planet's equator for nearly 300,000 kilometers, a distance roughly equal to 80% of the space between the Earth and the Moon, and yet in most places they are less than a kilometer thick. Imagine a sheet of paper. Now imagine that sheet of paper scaled up until it is the width of a city. That is the rings of Saturn. Wide beyond imagining, thin beyond believing, and they are made of ice, mostly ice, some rock, some dust. But the dominant material is water ice, frozen water, the same water you have touched, the same water that has moved through rivers and clouds and living things on this small planet, broken into billions of fragments ranging from grains the size of sugar crystals to boulders the size of houses, all of them tumbling slowly in the cold dark above Saturn's equator, all of them catching sunlight and throwing it back into space in a way that makes the whole system glow like something dreamed rather than something real. When Galileo pointed his early telescope at Saturn in 1610, he thought he was seeing a triple planet. The rings blurred at the edges of his primitive lens and resolved as two round shapes flanking the central disk. He wrote that Saturn appeared to have ears. He spent years puzzling over it, checking and rechecking, and when his telescope improved and the rings gradually tilted away from his line of sight, as they do every 15 years or so, presenting their edge to Earth and nearly disappearing, he wrote in frustration that Saturn had swallowed its own companions. He died without fully understanding what he had seen. It would take another 50 years and a better telescope, and a Dutch astronomer named Christian Huygens before the rings were recognised as rings. As a flat disk surrounding the planet, not moons, not ears, not solid at all, though that final part, the understanding that the rings are made of countless individual particles rather than one solid sheet, would take another 200 years to arrive. This is one of the things that makes Saturn's rings so remarkable, not just what they are, but how long it took us to see them clearly. We have been looking at them for 400 years, and we are still learning. The Cassini spacecraft, which orbited Saturn for 13 years between 2004 and 2017, sent back more information about the rings than all previous observations combined, and even now, years after Cassini plunged into Saturn's atmosphere and went silent, scientists are still sifting through everything it told us. Let that settle for a moment. 13 years of data. And still the questions outnumber the answers. We're drifting outward now, away from Earth. The familiar blue of home is behind you, shrinking. Mars passes at a distance, then the asteroid belt, a sparse scattering of rock and metal that looks nothing like the dense asteroid fields of science fiction. Just a wide region of space where a planet never quite formed, where material left over from the solar system's beginning still wanders in slow long orbits. Beyond that, Jupiter, enormous, striped with cloud bands in amber and cream, its own moons arrayed around it like a small solar system within the solar system. And then, beyond Jupiter, further out than you might expect, further out than your instincts tell you space should go, the light grows colder and the sun appears smaller, and there, suspended in the dark like something that should not exist, is Saturn. From a distance, even a great distance, the rings are visible. That is how prominent they are. That is how much they define the planet. Saturn without its rings would still be the second largest planet in the solar system, a gas giant of almost incomprehensible scale, but it would not be Saturn in the way we know Saturn. The rings are not an accessory, they are an identity. Closer now, the planet is growing in the dark ahead of you. The details are beginning to resolve, the pale golden colour of the cloud tops, the subtle banding of the atmosphere, the enormous shadow the planet casts across the rings on one side, a long dark wedge cutting through all that brightness. And the rings themselves, what looked like a single flat disk from far away, is now beginning to show its true complexity. There are gaps, distinct gaps between distinct rings, each one carrying a name. The largest gap, the most famous, was identified in 1675 by a French-Italian astronomer named Giovanni Cassini, and so, when NASA's most ambitious Saturn mission was launched, it carried his name. The Cassini division, as it is called, is a gap roughly 4,800 kilometers wide sitting between the two brightest and most visible ring bands. For a long time, astronomers thought it was simply empty space. Then, when telescopes improved, they found that it is not empty at all. It contains fainter, more dispersed ring material, and the reason it appears as a gap is that one of Saturn's moons, Mimas, sits in a gravitational relationship with particles in that region that slowly nudges them out of stable orbits. This is called orbital resonance, and it is one of the most elegant concepts in all of orbital mechanics. A particle sitting in the Cassini division completes exactly 2 orbits around Saturn for every 1 orbit that Mimas completes. And because of that perfect mathematical relationship, 2 to 1, simple as a heartbeat, the tiny gravitational tug of Mimas adds up over time, orbit after orbit after orbit, pulling particles slightly off course, destabilizing them, slowly clearing the region. The gap is not emptiness. The gap is a pattern. The gap is gravity doing arithmetic over millions of years. There are other gaps, smaller ones, created by the same principle. There are other moons doing similar work throughout the ring system, some of them so small and so close to the rings that they are called shepherd moons. They literally herd the ring particles, keeping certain bands sharply defined, preventing them from spreading out and blurring at the edges. Prometheus and Pandora flank the narrower ring from inside and outside, and as they travel in their orbits they leave patterns in the ring material. Ripples, kinks, braided structures, like 2 fingers being dragged slowly through fine pale sand. And the sand moves. This is something that takes a moment to absorb. The rings are not still. Nothing in this system is still. Every particle is moving, orbiting Saturn at speeds that vary with distance. The inner particles moving faster, the outer particles moving more slowly, all of them in constant circulation, and the whole system is dynamic in ways that the first ring watchers could not have imagined. Waves travel through the rings, density waves triggered by the gravitational influences of moons, rolling slowly outward like ripples in a pond that never reach a shore. When Cassini flew close, very close, sometimes threading the gap between the innermost rings and the top of Saturn's atmosphere, its instruments could hear the rings, not sound, of course. Sound cannot travel through the vacuum of space. But Cassini carried instruments that detected radio waves, plasma waves, electromagnetic signals, and in the data those instruments collected, scientists found patterns that, when converted to audio frequencies for human ears, sounded like something between wind and music. A low, complex hiss, a strange singing. The rings translated into sound. It is the kind of thing that makes the universe feel less like a fact and more like a poem. Now you are very close. The rings fill your entire field of vision. If you were hovering just above the plane of the rings, which Cassini did during certain phases of its mission, what you would see is not a flat surface but a 3-dimensional landscape of sorts. The rings cast shadows on each other. Certain large particles catch sunlight and gleam brighter than their neighbours. Boulders tumble end over end in slow rotation as they complete their orbits. Some regions of the rings are so dense that they appear nearly opaque, white and reflective as a snowfield. Others are translucent. You can see Saturn's cloud tops through them, distorted slightly by the scattering of the particles. The rings have colours, subtle ones. Most of the main ring material is white or pale grey, reflecting sunlight with high efficiency, because water ice is such an excellent reflector. But the outermost ring, the E-ring, which is faint and wide and diffuse, has a faintly blue tint. This is because it is made of particularly small, fine particles, mostly tiny ice grains ejected from the surface of Enceladus, one of Saturn's moons. These small particles scatter blue light differently than larger ones, and so the E-ring is blue in a way that is almost imperceptible but real. Enceladus. That name will come back. Something about Enceladus that science is still turning over, still studying, something the cameras caught that changed the way we think about what might be possible in this solar system. But that is for later. For now, stay here in the rings. There is a phenomenon in Saturn's rings called spokes, radial streaks, dark or bright depending on the angle of the light, that appear to extend outward from near the inner edge of the B-ring across its surface, like the spokes of a wheel. They were first photographed by Voyager in the early 1980s and immediately confused everyone. In a normal ring system, orbital mechanics should prevent spoke-shaped structures from existing for long. The differential rotation of the rings, with inner material moving faster than outer material, should shear any radial feature apart within hours, and spokes do disappear. But they also form again, over and over. The current best explanation involves the planet's magnetic field. Saturn is a powerful magnetic body. Its field is large and complex and it rotates with the planet, and it appears that charged particles lofted above the ring plane by some process get caught up in that magnetic field and swept radially outward, coating ring particles along the way and changing how they reflect light. The spoke forms, it rotates with the planet's magnetic field for a time. Then differential orbital motion pulls it apart and it fades. Then another forms. The spokes are a conversation between the planet and its rings, a slow, repeating conversation in the language of electromagnetism and gravity and ice. There is so much going on here that is invisible without instruments. The rings are embedded in Saturn's magnetosphere, that bubble of magnetic influence that extends far into space around the planet. Charged particles from the sun, the solar wind, are captured by the magnetosphere and channeled along magnetic field lines, and these particles collide with ring material, slowly altering it, darkening it in some places, brightening it in others. The rings are being continuously modified, continuously sculpted, by forces that operate at scales both too small and too large for human eyes to track without help. The rings are also young. This was one of Cassini's most surprising findings, and it changed everything scientists thought they knew about the history of Saturn. For decades, the assumption had been that the rings were ancient, formed at the same time as the planet itself, roughly 4.5 billion years ago, primordial material left over from the construction of the solar system. But Cassini's measurements suggested otherwise. The rings appear to be somewhere between 10 and 100 million years old, which, in cosmic terms, is extraordinarily young. The dinosaurs were still alive when the rings may have formed. The rings of Saturn, that defining feature of the most beautiful planet in the solar system, might be a relatively recent addition to the view. This raises a question that no one has fully answered. Where did the ring material come from? One current hypothesis is that a large moon of Saturn, perhaps the size of one of the existing mid-sized moons, was pulled close to the planet by gravitational forces and broken apart by tidal forces. The same stretching and squeezing that the Earth's gravity does to ocean water, but applied to rock and ice, applied with enough force to shatter a moon entirely and spread its material into a ring system. Another hypothesis involves a comet, a large comet that wandered too close and was torn apart. A third involves a collision between two moons. The evidence is not conclusive. The origin is still a mystery that science is actively working on. But there is something beautiful about the mystery itself, that this enormous, gorgeous thing hanging in the outer solar system, this structure so vast that you could lay the Earth's diameter across it more than 20 times, might have been born from a catastrophe, from something that was torn apart, and what remained was not wreckage, exactly. What remained was rings. You are still here, drifting just above the ring plane, and the light is extraordinary. Saturn is to one side, a soft amber disk enormous and close, and the sun is far away. At Saturn's distance, it provides only about 1% of the light it provides on Earth. So everything is dim, everything is in a kind of permanent dusk. But the rings catch and amplify that distant light. They gleam. The plane of the rings is luminous against the black. The temperature here is cold in ways that are almost impossible to relate to human experience. In the rings themselves, temperatures hover around -180 degrees Celsius. The ice does not melt. It does not sublime rapidly. It just drifts, particle by particle in its orbital path, cold and patient, unchanged for millions of years. And yet there is change, slow change. The rings are losing mass. Tiny particles in the innermost rings are pulled by a complex interplay of radiation pressure and Saturn's magnetic field down into the planet's atmosphere, a process called ring rain. Researchers using data from the Keck Observatory estimated that Saturn is absorbing material from its rings at a rate of several tons per second. At that rate, the rings as they currently exist might be gone, absorbed into the planet, dispersed by radiation, within a few 100 million years, which sounds like forever but is, in cosmic terms, a blink. We are seeing them at a special moment. The rings are here now. They may not always be here. And that strange knowledge that this beautiful thing is temporary, that we exist at the right moment in the solar system's history to look up and see Saturn's rings in the night sky, makes the view feel more precious rather than less. There is a way to see Saturn's rings from Earth with nothing more than a small telescope, a beginner's telescope, the kind that gets bought as gifts and sometimes never unpacked. Point it at Saturn on a clear night when Saturn is well placed in the sky and the rings will be there, not as a photograph, not through a space agency's instrumentation, just there, a tiny golden disk with a flat ring around it, suspended in the eyepiece. Thousands of people see it every year for the first time, and the reaction is almost always the same: disbelief that it is real. It looks like a sticker on the lens. It looks like a picture pasted over a dark background. It looks too neat, too orderly, too perfect to be a thing that simply exists. But it exists. It is as real as anything you have ever seen. The rings are composed of several named bands: the D ring, the C ring, the B ring, the A ring, the F ring, the G ring, and the E ring, moving from innermost to outermost. And each has its own character, its own density, its own population of particles, its own relationship to Saturn's moons and magnetic field. The B ring is the brightest and most opaque. The A ring contains the Encke gap and the Keeler gap, small cleared lanes maintained by small embedded moons. The C ring is faint and transparent, sometimes called the crepe ring because you can see through it. The D ring, which sits closest to Saturn, is so faint it was not even confirmed to exist until Voyager flew past in the 1980s. Between the named rings and beyond the named rings there is more material, faint halos and diffuse sheets of particles, so thin and so widely spaced that they are functionally invisible from Earth, but detectable by spacecraft instruments. The ring system, taken all together, extends from just above Saturn's upper atmosphere out to the orbit of Titan, Saturn's largest moon, a distance of more than 1 million kilometers. Most of that distance contains nothing but the ghost of a ring, the barest trace of material. But it is there. The system is wider than any single number suggests. There is something out there in the far edge of the ring system that Cassini detected but never fully explained. A faint, persistent structure, a pattern in the distribution of particles that seem to repeat at regular intervals, spaced too evenly to be random, too subtle to be tied to any known moon. Scientists noted it, filed it, returned to it without resolution. It may be an artifact of measurement. It may be something simple that has not been properly modelled yet. But there is a small chance, a real possibility sitting quietly at the edge of current knowledge, that it represents something new. Something about how ring systems self-organise in ways the current models do not fully capture. The universe is always doing that. Always sitting just at the edge of what you think you understand and offering something slightly beyond it. A question at the end of every answer. A new door inside every room you thought was fully explored. You are drifting now, still above the rings, and the motion is almost imperceptible. Saturn hangs large and steady. The rings extend in both directions beyond what you can take in at once, curving away to either side, catching the faint distant sunlight and returning it in a soft, even glow. The shadow of Saturn falls across a portion of the rings to one side. A hard geometric shadow, straight-edged and dark, cutting across all that brightness, like a line drawn with a ruler. In that shadow, the rings are not dark. They glow a faint reddish brown, lit by light that has bent around the limb of Saturn, by light scattered back from the planet's own atmosphere. The rings are never fully dark. Even in Saturn's shadow, they carry a faint self-illumination, a residual warmth caught from light that has already bounced and travelled and finally reached this quiet corner of the outer solar system. The icy particles in the shadow are not cold in the way you might imagine cold. They are beyond cold, below the threshold of temperatures that Earth's coldest places approach even in the middle of polar winter, and yet they carry that faint glow, that residual light, something reaching them even here, even in the shadow of a giant planet, even at 1.5 billion kilometers from the Sun. It is the kind of moment, floating in Saturn's shadow, watching the rings glow in indirect light, everything quiet and ancient and slow, where the scale of the universe tries to settle into you, and you feel something that is not quite awe and not quite smallness, but something in between, something that has no good word, something that comes from understanding, even partially, what surrounds you on all sides every night when you lie down in the dark. The rings turn, Saturn turns. The Sun is a bright distant point, not warm from here, not the generous flooding light you know from Earth, just a point of brilliance in the dark. And all around that point, in the long silence of the outer solar system, the rings are moving. They have been moving for millions of years without pause. They will continue moving. The shepherd moons will continue their herding, nudging particles back into line. The spokes will form and dissolve and form again. Ring rain will fall slowly into Saturn's clouds. The gaps will stay clear, swept by resonance and gravity, empty corridors in all that frozen splendour. And somewhere out here, past the visible rings, past the faint outer halos, past the orbit of Titan, something is drifting that arrived from very far away. A particle, perhaps, or a small fragment of ice, or a piece of a comet that wandered through the inner solar system long ago and made its slow way outward, and is now caught, barely caught, at the very outermost edge of Saturn's gravity, beginning a first slow orbit that will take thousands of years to complete. It has no idea, and it does not need one, that tonight from a small warm planet 1.5 billion kilometers away, something that calls itself a person is lying in the dark, breathing slowly and thinking about it. It is still out there, that slow drifting fragment, completing its first long arc around a planet it will never touch. And there are others like it, millions of others, caught in orbits so wide and so gradual that they exist in a kind of permanent in-between, neither free in interstellar space nor truly part of the ring system, just held, just suspended, just moving in the patient way that only very old things move. This is the outer boundary of Saturn's influence. Out here the gravity is gentle, more suggestion than force, and things linger rather than orbit with purpose. The ring system proper is far behind you now, still glowing faintly in the direction of the Sun. From this distance, from this far edge, the rings are a line, a single luminous line crossing the disk of the planet. It is almost impossible to believe from here that that line is 300,000 kilometers wide. Distance does that to things, compresses them, makes the vast appear simple. Turn your attention inward again, back toward the planet, back towards Saturn itself. Because the rings are extraordinary, yes, but they exist around something that deserves just as much careful attention. Saturn is not merely a backdrop for its rings. It is a world in its own right, a world of storms and winds and chemistry and mystery, and it has been turning silently in the outer solar system for 4.5 billion years, long before the rings were there to frame it. Saturn is a gas giant, which means it has no solid surface, or rather, it has no surface that a spacecraft or a person could land on. What Saturn has is atmosphere, layer upon layer of it, growing denser and hotter as you descend, until eventually the gas transitions into something more like liquid, and then into something stranger still. But from outside, from the top of the clouds, what you see is a banded world, lighter zones and darker belts, similar to Jupiter's, but softer, hazier, the contrast less stark. Saturn's upper atmosphere is rich in ammonia, and the haze of ammonia ice crystals that sits high above the main cloud layers softens the banding, smooths the contrast, gives the whole planet a kind of blurred golden quality, like Jupiter seen through frosted glass. The winds on Saturn are extraordinary. At the equator, the winds blow at roughly 1,700 kilometers per hour, not in gusts, continuously. A sustained equatorial wind of 1,700 kilometers per hour, wrapping the entire planet, moving without obstacle because there is no surface to create friction, no mountain range to deflect it, no ocean to absorb it. Just wind, circling a planet the size of Saturn, every hour of every year for as long as Saturn has existed. For context, the fastest surface winds ever recorded on Earth during a hurricane barely approach 350 kilometers per hour. Saturn's equatorial winds are nearly 5 times that, and they are the background condition, not a storm, just the ordinary state of the planet. And then there are the actual storms. In 2010, Cassini and Earth-based telescopes watched a storm erupt on Saturn that became known as the Great White Spot. It had nothing to do with Jupiter's Great Red Spot in terms of origin or mechanism, but it shared one quality: its scale was almost impossible to hold in the mind. The storm began as a bright white disturbance in Saturn's northern hemisphere and grew. Within weeks it had encircled the entire planet, a band of turbulence stretching all the way around Saturn at its latitude, churning and expanding until it covered an area greater than the surface area of Earth. The whole planet was encircled by this single storm system, wrapped in disturbance from horizon to horizon in every direction. These Great White Spot events happen on Saturn roughly once every Saturn year, and one Saturn year is 29 Earth years, so they are rare events by human timescales. The last few have been documented. Before that, records are fragmentary. Astronomers in the 1800s caught glimpses of earlier ones and noted bright disturbances in Saturn's clouds, not knowing what they were looking at, not knowing the scale. Just a bright white patch that appeared and grew and slowly faded back into the ambient banding. The storms are driven by convection, the same process that drives thunderstorms on Earth, where warm, moist air rises, cools, drops its moisture as rain, and descends again. On Saturn, instead of water, the atmosphere uses ammonia. Warm ammonia-rich gas rises from the deep interior, reaches a level where the temperature drops enough to cause the ammonia to freeze out and releases enormous amounts of energy in the process. This energy drives the upward surge of the storm head, which is the bright white feature visible from outside. The storm is, in essence, a planetary thunderstorm, running on ammonia, circling a gas giant, lasting for months. Inside those storms, there is lightning. Saturn's lightning was detected by Cassini, not seen directly, but heard, in a sense, through the radio receivers on the spacecraft. Saturn's lightning generates radio emissions, and those emissions crackle in the data like static, like the sound of a distant station coming in and out of the range. The discharges are estimated to be roughly 1,000 times more powerful than a typical lightning bolt on Earth. In a storm that covers more surface area than Earth itself, there is no quiet on Saturn. Beneath the storm clouds, deeper into the atmosphere, the temperature climbs and the pressure climbs. The gas becomes denser, chemistry becomes more complex. At some depth, not precisely known because no probe has survived long enough to reach it, the hydrogen that makes up most of Saturn's atmosphere transitions into a phase that does not exist on Earth. Liquid metallic hydrogen. Hydrogen compressed so tightly and under such pressure that its electrons are no longer bound to individual atoms but flow freely through the material, making it behave not like a gas or a liquid but like a metal, like a conductor. This liquid metallic hydrogen layer is the source of Saturn's magnetic field. As it rotates with the planet, and Saturn rotates quickly, completing a full rotation in just under 11 hours, the flowing currents of metallic hydrogen generate a magnetic field through a process called the dynamo effect, the same process that generates Earth's magnetic field in the liquid iron outer core. Saturn's magnetic field is smaller than Jupiter's, but still enormous by Earth standards, extending hundreds of thousands of kilometers into space and shaping the behavior of charged particles throughout the entire Saturn system. The magnetic field is also, strangely, almost perfectly aligned with the planet's rotation axis. On Earth, the magnetic North Pole is offset from the geographic North Pole by about 11 degrees. On Saturn, the alignment is almost exact, less than a fraction of a degree of offset. This is deeply puzzling to planetary scientists because the dynamo models that explain how planetary magnetic fields are generated generally require some tilt to function. A perfectly aligned dynamo should not work as well as Saturn's dynamo clearly does. This is one of the long-standing mysteries of Saturn, sitting quietly in the data, waiting for a theoretical framework good enough to explain it. The planet keeps its secrets, even after 4 centuries of watching, even after 13 years of a dedicated spacecraft. Even now, with all the data still being analysed, Saturn is not a problem that has been solved. It is a place that has been visited partially and partially understood, and left still with more questions than answers. Come back to the surface of the clouds now, back to that banded amber gold. There is something in Saturn's northern polar region that stops every conversation when it is first described to someone who's not heard it. A hexagonal cloud pattern, not approximately hexagonal, not loosely hexagonal. A precise, stable, repeating 6-sided geometric shape, each side roughly 14,000 kilometers long, wider than Earth itself, sitting at the North Pole and persisting year after year after year. The hexagon was first imaged by Voyager in the early 1980s. When Cassini arrived decades later, it was still there, unchanged, still 6-sided, still rotating, still persisting through seasons and storms and the passage of planetary years. The same hexagon, the same shape, the same storm system, because that is what it is, a persistent wave pattern in Saturn's upper atmosphere that Voyager photographed 30 years before. How does a storm become a hexagon? The answer is fluid dynamics. The hexagonal shape is a standing wave, a wave pattern that forms at a specific latitude in Saturn's atmosphere, where wind speeds create a resonance condition. Under certain conditions, rotating fluids spontaneously create polygonal patterns rather than circles. You can reproduce this in a laboratory on Earth, spinning cylinders of water at different speeds and watching hexagons form at the boundary between the fast inner rotation and the slower outer fluid. The physics is the same on Saturn, just enormously larger, just enormously more persistent. Inside the hexagon sits a massive cyclone, a permanent polar storm with an eye at its centre so large that the entire continental United States could fit inside it. The eye is clear, or relatively clear, and through it you can see down into Saturn's atmosphere, deeper than the surrounding clouds allow, into a dimmer, deeper layer of the atmosphere that ordinarily stays hidden. It is like looking through a window in the clouds, a 6-sided window, a window 14,000 kilometers across. Cassini photographed the hexagon and the polar cyclone in detail, and the images are among the most visually striking ever taken of another planet. The hexagon is dark at the boundaries and bright near the centre in some wavelengths, giving it the look of something designed rather than something natural. But it was not designed. It simply is what fluid dynamics looks like at planetary scale when given enough time and space and energy. Everything on Saturn is like this. Everything you look at reveals a physics principle operating at a scale you cannot get on Earth. The rings are orbital mechanics. The banding is fluid dynamics. The storms are convection. The magnetic field is the dynamo effect. The hexagon is standing wave resonance. Saturn is like a textbook that has come to life and grown to the size of a small star, and wandered out into the cold of the outer solar system, and been turning there quietly, running all its demonstrations for 4.5 billion years. It does not need an audience. It did not form to be observed. It does not perform its hexagonal storm and its metallic hydrogen interior and its 300,000 kilometer rings for the benefit of anything. It simply is these things. It was these things long before there was a word for any of them. Long before there was a word at all. Now let your attention move to the moons. There are many of them. Saturn has more confirmed moons than any other planet in the solar system. Well over 100, though most are small captured objects, dark and irregular, following inclined orbits that suggest they arrived from elsewhere, and were caught rather than forming alongside the planet. The larger moons are different. The larger moons formed with Saturn, from the same disk of material that surrounded the young planet in the early solar system, and they are worlds. Real worlds, each one different from the others, each one with its own geology and chemistry and history. Titan is the largest. Titan is so large that for a long time some astronomers classified it as a planet-sized object in its own right, and it is larger than the planet Mercury. It is the only moon in the solar system with a thick atmosphere. Not a thin trace atmosphere, not the barely there envelope of gas that some other moons possess, but a dense nitrogen atmosphere with a surface pressure 1.5 times the surface pressure on Earth at sea level. Standing on Titan, if you could, you would not need a pressure suit to prevent your body from being crushed or decompressed. You would need warmth, because the surface temperature is minus 179 degrees Celsius, and you would need oxygen, because there is none in Titan's atmosphere. But the pressure itself would not kill you. Through Titan's thick haze, the sun is not visible. The sky is orange. A deep, thick, organic orange haze fills the atmosphere from surface to stratosphere, created by complex chemistry in the upper atmosphere, where ultraviolet light from the sun breaks apart nitrogen and methane molecules, and they recombine into long-chain organic compounds, tholins they're called, that drift slowly down through the atmosphere and coat the surface in an orange sediment. And on the surface there are lakes, real lakes, detected by Cassini's radar instruments, liquid lakes and seas sitting in the polar regions of Titan. Not water. The temperature is far too cold for water to exist as a liquid on Titan's surface. These are lakes of methane and ethane, liquid natural gas essentially, sitting in basins carved by liquid flow, with shorelines and bays and islands, with what appear to be waves on their surfaces under the right wind conditions. The largest is called Kraken Mare. It covers an area larger than the Caspian Sea. It rains methane on Titan. The rain falls through that orange haze in large, slow drops. Because Titan's gravity is lower than Earth's, and the atmosphere is denser, the drops fall more slowly and are bigger than Earth raindrops. They hit the orange surface and run downhill in rivers of liquid methane, carving channels and valleys, filling the polar lakes, evaporating eventually and rising again into the haze to begin the cycle again. A methane water cycle, analogue to Earth's water cycle, running on the surface of a moon of Saturn at a temperature that would freeze solid every substance we build our ordinary lives around. And below Titan's surface, below that orange crust of tholins and ice, there may be a liquid water ocean. Gravity measurements suggest an internal liquid layer. The tidal forces Saturn exerts on Titan may be generating enough heat in the interior to keep a buried ocean of water liquid beneath the ice. An ocean that has never seen sunlight, never experienced weather, never been touched by anything from the outside universe. If there is life in that ocean, and there is no evidence yet that there is, and no certainty that there could be, it would know nothing of Saturn's rings. Nothing of the hexagonal storm, nothing of the methane rain falling overhead on the surface. It would know only its own dark water, its own chemistry, its own slow centuries. But we are getting ahead of ourselves, or perhaps behind. The story of what might exist in Saturn's hidden oceans belongs to another night. For now, stay with what is visible, what is certain, what the instruments have confirmed, because there is still the matter of Enceladus, small Enceladus, white Enceladus, a moon that should be geologically dead. It is only about 500 kilometers across, far too small to retain the internal heat that drives volcanism on larger worlds. And yet it is one of the most active geological bodies in the entire solar system. In 2005, Cassini flew past Enceladus, and its instruments detected water vapour, not a trace, not an ambiguous signal. Water vapour, venting from the south polar region of the moon, in distinct plumes that rose hundreds of kilometres above the surface, and then fell back, and also escaped entirely into space, feeding material into Saturn's E-ring. The blue ring, the faint outer ring, with the fine ice particles that scatter blue light. That ring is made, at least in part, of material ejected from Enceladus. Cassini flew through those plumes. It flew through them multiple times, sampling the material as it passed, and what it found in the plumes changed everything. Water, ice particles, carbon dioxide, methane, molecular hydrogen, complex organic molecules, and silica nanoparticles, tiny grains of silicon dioxide that form when water at high temperature interacts with rock. That last ingredient was particularly important. Silica nanoparticles of the size and type that Cassini detected form in a very specific environment, hydrothermal vents, where hot water moves through rock at temperatures above 90 degrees Celsius. The presence of these silica grains in Enceladus's plumes means that somewhere inside that small white moon, water is in contact with warm rock, which means there is a liquid ocean inside Enceladus. Beneath the ice shell, beneath the frozen surface, a global ocean of liquid water that is in contact with a rocky seafloor and being heated from below. Enceladus is 500 kilometers across. It is smaller than the state of Texas. It should be frozen all the way through. Instead, it has a warm subsurface ocean with hydrothermal vents on its floor, and it is venting material from that ocean into space through cracks in its south polar ice shell, in plumes that Cassini flew through and tasted. On Earth, hydrothermal vents on the seafloor host entire ecosystems, creatures that have never seen sunlight, that do not depend on photosynthesis, that run their metabolisms on the chemical energy of the vent fluids. The discovery that Enceladus has these same conditions — liquid water, rocky seafloor, hydrothermal activity, organic chemistry, molecular hydrogen — was not evidence of life, but it was evidence that the conditions necessary for life as we understand it are present right now inside a moon of Saturn that is small enough to fit inside a medium-sized country. The plumes are still venting, right now as you read this, as you lie in the dark, as Saturn turns in the outer solar system and its rings catch the faint sunlight. Enceladus is venting. Water from its internal ocean is rising through cracks in the ice, crystallizing in the cold of space and drifting outward into Saturn's E-ring, where it becomes part of that faint blue halo of particles orbiting the planet. Water from an ocean we have never seen, feeding a ring we can photograph from Earth with the right telescope, travelling a path from deep ice to open space to the edge of Saturn's gravity, over and over and over again. The solar system is full of this, full of things that should not exist but do, full of conditions that could not have been predicted but are there when you look, full of quiet processes running in the dark on worlds we have only barely glimpsed, in oceans that no sunlight has ever touched, in storms that have been turning since before humans stood upright, in rings that glow in a light so faint and so cold and so far away that the photons reaching them left the sun at a fraction of their original brightness. And all of it is moving, right now, not in the past, not in photographs. Right now, in the present moment, Saturn is turning. Its rings are circling. Enceladus is venting. Titan's methane rain is falling through orange haze. The great polar hexagon is persisting at the North Pole, running its standing wave pattern without interruption, the same six-sided shape it has held since before Voyager first photographed it. You are very far from Saturn, farther than a number meaningfully conveys, but you've been there tonight, in the way that the mind can travel, through science, through description, through the slow accumulation of details that build a place out of facts and distance. You have seen the rings in their complexity. You have descended into the storms. You have flown through the plumes of Enceladus. You have looked down into the polar cyclone through its six-sided window. The outer solar system is very quiet from here. The sun is a bright point, patient and small. Saturn is a golden disk with a line across its equator. The line is the rings, of course, always the rings, defining the planet from any distance, in any light. Something about that line, that simple, perfect, improbable line, makes the universe feel arranged, not designed, not intentional, but arranged in the way that beauty sometimes arranges itself by accident, through physics and time and the ordinary operation of gravity. The rings did not form to be beautiful. They formed because a moon was torn apart, or a comet came too close, or some impact sent materials spraying into the right orbit at the right angle, and gravity did the rest. They are an accident of mechanics, and they are among the most beautiful things in the solar system. That tension between the mechanical and the beautiful is everywhere out here. The hexagon is geometry made weather. The plumes of Enceladus are geology made visible. The rings are catastrophe made luminous. And somewhere beyond the E-ring, somewhere past the outermost halo of Saturn's influence, that slow drifting fragment of ice from earlier is still completing its first long arc. Its orbit so wide that a human lifetime would not be enough to watch it complete even a fraction of the curve. It does not hurry. It has no reason to. And that is perhaps the most settling thing about this place. The scale of time out here is so vast that urgency becomes meaningless. The rings have been circling for millions of years. The storms have been turning for centuries. Titan's methane rain has been falling through its orange haze since long before anything on Earth thought to look upward and wonder what was out there. Saturn does not operate on a human schedule. It does not recognize the difference between a Tuesday and a Thursday, between morning and midnight, between a year of difficulty and a year of ease. It simply continues. It simply turns. There is a kind of relief in that. Not the relief of being told that things will be fine, Saturn makes no such promise, but the relief of perspective, of understanding, even briefly, even imperfectly, that the universe is very large and very old, and that it was running long before any particular problem existed, and will continue running long after every current problem has dissolved back into the larger story of things. The largest story. The one that started roughly 4.5 billion years ago with a cloud of gas and dust beginning to collapse under its own gravity, spinning faster as it collapsed, flattening into a disk, condensing at the centre into a star and throughout the disk into planets and moons and rings and all the rest of it. Saturn formed in the outer part of that disk, where temperatures were cold enough for ices to exist alongside rock and metal, and so it gathered not just the heavier materials but the light ones too. Hydrogen, helium, water, methane, ammonia. And it grew large. Larger than any other planet in the solar system except Jupiter. Large enough that its gravity influenced the orbits of objects throughout the outer solar system, shepherding some, ejecting others, shaping the architecture of everything beyond the asteroid belt. Saturn has been doing this work for 4.5 billion years. It is still doing it now. Every small moon in an irregular orbit, every comet that crosses the outer solar system, every Kuiper belt object that wanders too close. Saturn's gravity is part of the calculation, part of the constant background negotiation of forces that keeps the solar system in its current configuration. Remove Saturn, and the solar system would be different in ways that would take centuries of careful calculation to fully trace. The planet is not just a beautiful object in the night sky, it is a structural element, a load-bearing wall in the architecture of the neighbourhood. The rings, for all their beauty, are thin. You know this now, paper-thin relative to their width. And there is something in that thinness that speaks to a kind of precision. Not designed precision, but the precision that emerges from physics operating without interference. The particles in the rings have settled into the plane of Saturn's equator, because that is the lowest energy configuration. That is where orbital mechanics wants them to be. They did not choose it. They were arranged there by force and time, and the result is a structure so flat, so planar, so exactly arranged that it looks like someone drew a line across the planet with a steady hand. Nature makes these things. Given enough time and the right forces, nature makes hexagons and rings and hydrothermal vents under ice, and orange haze over methane lakes. It makes them without intending to. It makes them because physics, running long enough, finds these configurations and settles into them. There is a word for this tendency: self-organization. The universe has a tendency toward self-organization, toward the emergence of structure from the interplay of simple forces over long times, planets from dust, rings from catastrophe, storms from convection, chemistry from energy. And something stranger perhaps from chemistry. But that is a longer conversation, and tonight we are staying with what is visible, what is confirmed, what the cameras have captured and the instruments have measured. The cameras have captured a great deal. The Voyager flybys in 1980 and 1981 gave us our first close look. Quick, breathless passes that returned images scientists studied for years afterward. Then the long wait. Then Cassini, launching in 1997, arriving at Saturn in 2004 after a 7-year journey, settling into orbit and beginning its 13-year residency. 13 years of slow, methodical, patient observation. Orbit after orbit after orbit, each one slightly different, each one revealing something new. Cassini's final orbits were called the Grand Finale. In the last months of the mission, engineers directed the spacecraft into a series of orbits that took it between the innermost rings and the top of Saturn's atmosphere, the gap between them only about 2,000 kilometers wide, a region no spacecraft had ever entered before. Cassini threaded that gap 22 times, sampling the material there, measuring the magnetic field at closer range than ever, looking down into Saturn's clouds from just above, looking out at the rings from just below. And then, on the 15th of September 2017, out of fuel and near the end of its operational life, Cassini was directed into Saturn's atmosphere. It was a deliberate end, chosen to ensure that the spacecraft would not contaminate any of Saturn's moons, particularly Enceladus, with its subsurface ocean, with terrestrial microbes that might have survived the journey. Cassini was too valuable as a potential biological hazard to be left drifting, so it was sent in. For as long as it could, it transmitted, falling through the upper atmosphere, beginning to tumble as the thin gas thickened around it, sending data back at the speed of light across 1.5 billion kilometers to the receivers on Earth. The signals took about 83 minutes to arrive. By the time the final signal reached Earth, Cassini had already been gone for over an hour. It was already part of Saturn. Its material, the metal and the instruments and everything it had been, was already mixing with the hydrogen and helium of the planet's atmosphere, descending into depth that no instrument will reach again for a long time. There is something in that ending that feels right. Cassini began as a human-made thing and ended as part of Saturn. The boundary between the observer and the observed, usually so clear, dissolved. It became the planet it had been studying for 13 years, the longest field study in the outer solar system, concluded by becoming part of the subject. The data it sent back will take decades more to fully analyse. There are still papers being published, still discoveries being made, still questions being refined by scientists working through the archive of everything Cassini saw and measured and sampled and transmitted. In some sense, Cassini is still working. Its data is still yielding. The mission is not over. Only the spacecraft is. Future missions are being planned. There is serious scientific discussion of a return to Saturn, a dedicated mission to Enceladus, specifically. A spacecraft that would orbit that small white moon and fly through its plumes repeatedly, carrying instruments designed to search for signs of biology in the water that rises from the hidden ocean. Such a mission has not been launched yet. It is in the stage of proposals and cost estimates, and the long, slow process of building scientific consensus and funding. But the intent is there. The interest is there. We will go back. Humanity has this quality, this persistent, sometimes impractical, always admirable insistence on going back, on looking again, on sending another spacecraft, another telescope, another probe into the dark, because the last one raised questions that the answers to raised more questions, and the questions are too interesting to leave alone. The universe keeps offering the next room and we keep walking through the door. Saturn is a door that has been opened many times, and each time reveals a longer corridor than expected. Galileo opened it in 1610 and found something he could not explain. Huygens opened it in 1655 and found rings. Maxwell opened it mathematically in the 1850s and proved the rings must be made of particles rather than a solid sheet. A theoretical prediction confirmed a century later by direct observation. Voyager opened it in 1980 and found shepherd moons and spokes and the complexity of the ring system's inner structure. Cassini opened it in 2004 and found a plume-venting ocean moon and a hexagonal polar storm in silica nanoparticles speaking of hydrothermal activity in a hidden sea. Each answer a door, each door a corridor, the corridor still going. It is a good thing to carry into sleep. Not the anxiety of unanswered questions, but the comfort of them. The universe is not finished revealing itself. There are oceans under ice that no light has ever touched. There are ring systems we have only partially mapped. There are storm patterns that have been turning longer than our species has existed. And tomorrow, or next year, or in the next decade, someone will look more carefully at the data and find something new in it. A pattern in the particle distribution, a signal in the magnetic field measurements, a chemistry in the plume material that was there all along waiting for the right question to be asked of it. The rings are still there. Right now, as you move towards sleep, Saturn is in the outer solar system, and its rings are catching whatever small fraction of sunlight reaches them at that distance, and returning it quietly into the dark. The shepherd moons are completing their orbits. The hexagon is persisting. Enceladus is venting. The solar system does not pause while we sleep. The planets do not wait. The orbits continue, the storms continue, the slow rain of ring particles into Saturn's atmosphere continues. Everything is in motion, everything is following its path, and all of it will be there tomorrow, unchanged in any way that matters, patient and ancient and still going. The rings of Saturn, 300,000 kilometers wide, less than a kilometer thick, made of ice, made of catastrophe, made of time, glowing in the outer dark like a line drawn by a steady hand across the face of the most beautiful planet in the solar system. Still moving, still circling, still there. Let that be the last thing. Not conclusion, not an ending. Just the image of it. That thin, luminous line, that improbable structure, those billions of ice particles, each following its own orbit. each one a small cold piece of something that was once whole, now part of something wider and stranger and more beautiful than the whole thing ever was. The universe makes things like this. It has been making them for a long time. It will keep making them after we are gone. And somehow, in the making of all of it, it made something capable of lying in the dark on a small warm planet and thinking about rings of ice around a distant golden giant and feeling, quietly, something that has no name. The light that left the sun this morning will reach Saturn in about 80 minutes. It travels the whole distance, all 1,430,000,000 kilometers of it, and arrives diminished, pale, a fraction of the warmth and brightness it carried when it left, and yet the rings catch it. The ice particles, each one tumbling in its own quiet orbit, accept that weakened light and give it back. The whole ring system glows with light that has travelled over an hour to reach it, and is now travelling back outward into the dark in all directions, including the direction of Earth, including the direction of a small telescope pointed by someone standing in their backyard in the cool of an autumn evening, looking up, finding that pale golden disk with the line across it and going very still. This is what light does. It travels, it diminishes, it arrives anyway. There are other ring systems in the solar system. Jupiter has a faint ring, discovered by Voyager in 1979, so thin and dark that it is invisible from Earth, even with the best telescopes, and was not suspected until a spacecraft flew out and looked back. Uranus has rings, narrow, dark, made of material so unreflective that astronomers only discovered them by accident in 1977, watching a star pass behind Uranus and noticing the starlight dimming briefly not once but multiple times, once on each side as the rings crossed in front of it. Neptune has rings too, incomplete arcs in some cases, clumps of material distributed unevenly around the planet, held in place by shepherd moons that prevent them from spreading into uniform bands. But none of them are Saturn's rings. Saturn's rings are in a category of their own, not because of pride or sentiment, but because of physics, because the combination of Saturn's mass, its distance from the Sun, the temperature at that distance, the composition of the material available, and whatever catastrophic event triggered the ring formation, all came together in a way that produced something of exceptional brightness and exceptional scale. The other ring systems exist. They are interesting, they are worth studying. But they do not glow. They do not define their planet from across the solar system. They do not appear through a backyard telescope as something that stops you mid-breath. Saturn's rings are a specific accident of specific conditions at a specific moment in the history of the solar system. They will not last forever. The ring rain is slowly drawing them down into the planet. The particles are gradually being absorbed or dispersed. In a few 100 million years, perhaps less, what we see now will be significantly diminished, perhaps unrecognizable from what exists tonight. Future civilizations, if they exist, may look at Saturn through their instruments and see a planet with only the faintest trace of rings. They may read about what once was there the way we read about things that existed before the first human wrote anything down. We are seeing the rings at their moment of fullness, or near it. This particular view, this particular brightness, this particular extent and complexity, it belongs to now, to this period of solar system history, to these centuries of human observation, to tonight. There is something about that which makes the darkness outside feel different. Not smaller, not less vast, but differently inhabited. The outer solar system is not just empty space and cold objects following their paths in silence. It is a system of things in specific relationships at a specific moment, and that moment includes you lying in the dark, and the rings catching the last of the sun's diminished light, and Enceladus venting water from its hidden ocean, and Titan's methane rain falling slowly through orange haze onto a surface no human has ever touched. All of it simultaneous, all of it right now. The mind finds it difficult to hold simultaneity at this scale. We are accustomed to thinking of distant things as separate from the present moment, as facts, as data, as images in a textbook or on a screen. But the rings are not a photograph. They are not historical. They are present tense. They are happening now in the same moment that you are breathing, in the same moment that this sentence is reaching you, in the same moment that the room around you is warm and quiet and the day is finally, genuinely over. The rings do not know they are being thought about. They do not require attention to continue their work. But something changes perhaps in the one doing the thinking, some small shift in the scale at which the world is being perceived, some slight loosening of the grip on the immediate and the local, some opening toward the vast and the patient and the ancient. That loosening is what this journey has been for, not to fill your mind with facts, though the facts are real and worth carrying, not to overwhelm with scale, though the scale is genuinely overwhelming if you let it settle, but to give the smaller things somewhere to rest. To offer the mind a space so wide and so old and so indifferent to urgency that the urgent things can, for a little while, become what they actually are. Small events in a large universe, moments in a long story, things that matter but do not need to matter tonight, here, in the dark, while Saturn turns. The rings are still catching light. Enceladus is still venting. The hexagon is persisting, six-sided and patient, at the north pole of a planet you cannot see with the naked eye tonight, but that is there, has always been there during every night of your life, turning in the outer dark at the same distance it has maintained for 4.5 billion years. Cassini is gone, absorbed into the planet it studied. Its data is still being read, its measurements are still yielding. The mission that ended with a spacecraft becoming part of a planet is still, in a quiet sense, continuing. In the papers being written, in the questions being refined, in the next mission being planned, in the slow, patient work of people who have given their working lives to understanding a planet that will never know they exist. There is something in that devotion that feels worth noting here, at this late and quiet hour. The scientist who built Cassini and flew it, and interpreted its data and mourned its end, and went back to work the next morning. They did that work for the same reason that you might lie awake sometimes thinking about the universe. Not because it is practical, not because it solves anything immediate, but because there is something in human attention that reaches naturally toward the large and the old and the beautiful, something that is not satisfied by the local and the immediate alone, something that needs, occasionally gently in the dark, to be reminded that it is part of something very much larger than itself. The rings provide that, effortlessly, without trying. The pace is slower now. The sentences are finding their length. The journey has covered a great distance tonight, from the first simple description of a ring made of ice, through the complexity of the ring bands and the shepherd moons and the spokes, through Saturn's storms and metallic hydrogen interior and hexagonal polar vortex, through Titan's orange atmosphere and methane lakes, through the plumes of Enceladus and what they mean, and all of it has been moving toward this quiet, this late moment in the dark, this slowing. The rings are narrowing. Not actually, they're exactly as they were when we first arrived, but in the way that things narrow as attention softens. The detail is becoming less important than the quality. The specific facts are settling beneath the general feeling. The mind is moving from knowing towards simply being, and that movement is natural and it is good, and it is what the body has been waiting for since long before this story began. Saturn is far away. The rings catch light. The dark between here and there is enormous, and it is not empty, and it is not threatening. It is just space. The ordinary medium of the solar system, the ordinary nothing through which all these extraordinary things are moving, have always been moving, will continue to move. You are breathing now the way the rings move, not quickly, not with urgency, just continuing. Just following the path that the body knows without instruction, the rhythm it has maintained without interruption since the first moment of this life. The same rhythm that will carry you through the night and into whatever tomorrow holds. But that is tomorrow, and it can wait. Tonight there is only this: the dark, the distance, the rings. The ice is very old. Some of it may carry within its crystalline structure a record of the conditions under which it formed. Traces of chemistry, traces of temperature, traces of the moment when a moon was broken apart and its material spread into a ring. Scientists study ice cores on Earth to read the history of climate preserved in layers of frozen water. The ice in Saturn's rings is a different kind of record. A record of catastrophe and time and the patient sorting action of orbital mechanics. Every particle in the rings is in the exact orbit that physics requires for it. Not an inch higher, not an inch lower than where the balance of gravity and velocity places it. The rings are, in this sense, a perfect system. Not perfect in the sense of flawless, not perfect in the sense of intended, but perfect in the sense of exactly what the forces involved would produce. A direct expression of physics, a shape drawn by law. The outermost wisps of the ring system are thinning now as we drift slowly away. The bright central bands, the B ring and the A ring, are receding. The planet itself is growing smaller, the golden disk, the line across it, becoming again with distance the simple image it appeared as when you were very young, and first saw a picture of it and thought it looked unreal. It still looks unreal, it is completely real. Both of these things are permanently true and neither cancels the other, and there is something restful in that, in the idea that something can be simultaneously beyond belief and absolutely certain, that wonder and knowledge can occupy the same space without one diminishing the other, that you can know exactly what the rings are made of and still feel, looking at them, that the universe has done something improbable and beautiful, and that you are fortunate to exist at a moment when you can know it. Saturn is distant now, a point almost. The rings invisible at this scale without instruments. The whole system, planet, rings, moons, plumes, hexagon, hidden ocean, compressed by distance back into a pale dot in the outer dark. But it is there. It will be there tomorrow. It will be there when you wake into whatever the morning brings, unchanged, still turning, still ringed, still running its ancient demonstrations of physics and time in the cold and patient dark. The rings will still be catching light, and somewhere in the faint blue halo of the E-ring, a particle of ice that was once part of an ocean under ice will be completing another small arc of its orbit, moving the way everything out here moves, without urgency, without destination, following the only path available, continuing simply because continuing is what things in orbit do. The pale dot that Saturn has become from this distance is deceptive. Distance compresses everything into simplicity. A point of light, a dot in a photograph, a number in an astronomical table. But we have been there. We have seen what that dot contains. And now the journey turns, not back toward Earth, not toward rest, but outward, further. Because the solar system does not end at Saturn, and the universe does not end at the solar system, and there is always more corridor beyond the door. Past Saturn, the temperature drops further. The sun's light, already weakened to roughly 1% of its Earth surface brightness at Saturn's distance, continues to thin. At Uranus, twice as far from the sun as Saturn, the light is a quarter of what it was at Saturn. At Neptune, further still, it is less than that. And beyond Neptune, the light becomes something more symbolic than functional. Present, measurable, but no longer capable of warming anything. No longer the generous flooding source it is on Earth. Just a bright star, the brightest star in the sky from out there, but a star nonetheless. The outer solar system beyond Neptune is called the Kuiper Belt, a vast region of frozen objects, dwarf planets, comets in waiting, primordial debris left over from the solar system's construction, stretching from Neptune's orbit outward for billions of kilometers. Pluto is there, reclassified but not diminished, a world of nitrogen ice plains and mountain ranges of water ice, and a thin atmosphere that freezes and falls as snow when Pluto moves further from the Sun in its long elliptical orbit. Eris is there, roughly Pluto's size, even further out, colder, darker, its surface coated in methane frost. Make, Haumea, which rotates so fast, once every 4 hours, that it has been stretched into an egg shape by the centrifugal force of its own spin. These are not failed planets. They are not minor objects in the sense of being unimportant. They are the original material of the outer solar system, the stuff that did not get incorporated into the giant planets, preserved in cold storage at the edge of the Sun's domain. They are older than anything on Earth. Older than Earth itself in the sense that their material predates the formation of the planets, carrying within their ice and rock a chemical record of the solar system's beginning. Some of them have moons. Pluto has 5, the largest of which, Charon, is so big relative to Pluto that the two are sometimes called a double dwarf planet system, rather than a planet and its moon. Charon does not orbit Pluto in the way the moon orbits Earth, with the smaller body circling the larger one. Instead, both Pluto and Charon orbit a point in space that lies between them, above Pluto's surface. They are tidally locked to each other, each showing the same face to the other at all times, turning together in a slow mutual orbit, each one fixed in the other's sky, never rising, never setting, just hanging there. Imagine that. A world where the largest object in the sky never moves. where it is simply always there, in the same position, day after day, year after year, which on Pluto means every 6.5 Earth days, the length of one Pluto day, one full rotation. Charon hanging motionless while the stars wheel slowly around it, a companion that never leaves. New Horizons flew past Pluto in July 2015, the first spacecraft ever to visit the outermost regions of the classical solar system, and what it found there surprised everyone. Not an inert frozen rock. A world with geology. A world with a heart, literally. A vast nitrogen ice plain in the shape of a heart, now called Tombor Regio after Clyde Tombaugh, the astronomer who discovered Pluto in 1930. The left lobe of the heart is a glacial plain of nitrogen ice, smooth and young. Geologically young, meaning its surface has been refreshed recently enough that craters have not had time to accumulate. Something is renewing that surface. Some process of convection in the nitrogen ice, cells of warmer ice rising and cooler ice sinking, slowly churning the surface and erasing the impact record. On a world with no internal heat source, large enough to explain this. On a world 4 billion kilometers from the Sun. On a world that should, by all prior reasoning, be frozen solid and static and ancient and scarred. Pluto is doing something. It is not finished. It is still active, still churning, still renewing itself in some way that the models of 2015 did not predict and that scientists are still working to fully explain. There is talk of a possible subsurface ocean on Pluto as well. Liquid water, kept from freezing by some combination of antifreeze chemistry and residual internal heat, though the evidence is less certain than for Enceladus. But the possibility sits there, in the data, refusing to be entirely dismissed. The solar system keeps doing this, keeps producing activity where stillness was expected, keeps hiding liquid water under ice in places too cold and too far from the sun for liquid water to have any business existing, keeps running processes in the dark that our models, built from Earth-centric assumptions, did not anticipate. Water is remarkably persistent. It freezes on surfaces, it hides underground, it vents through cracks, it circulates in oceans under kilometers of ice. Everywhere the solar system has been looked at carefully, water has been found. On the Moon, in permanently shadowed craters at the poles. On Mars, in subsurface ice deposits and possibly in liquid form in deep underground reservoirs. On Europa and Ganymede and Callisto, moons of Jupiter with subsurface oceans. On Enceladus, possibly on Titan, possibly on Pluto. The solar system is not dry. It is saturated with water in various forms, distributed across dozens of worlds, waiting under ice or locked in rock or venting into space in frozen plumes. This matters because water is the medium in which the chemistry of life, as we understand it, operates. The solar system being full of water is not a guarantee of anything. Water is necessary but not sufficient, but it means that one of the key requirements for the kind of chemistry that produced life on Earth is not rare. It is not confined to Earth. It is everywhere the instruments have looked in quantities that range from traces to oceans. The question of what that means remains genuinely open. Beyond the Kuiper Belt, past the scattered disk of objects that extends even further, past Sedna, a strange reddish world in an orbit so elongated that it takes 11,000 years to complete one circuit of the Sun, there is a region that has not been directly observed, but whose existence is inferred from the behaviour of long-period comets, the Oort Cloud. A vast spherical shell of icy objects surrounding the solar system at distances of up to 100,000 astronomical units from the Sun, roughly a quarter of the way to the nearest star. The Oort Cloud is the solar system's outermost boundary, or its outermost reservoir. A shell of primordial material, trillions of objects held loosely by the Sun's gravity at such enormous distances that the occasional gravitational nudge from a passing star or the galactic tide is enough to send one of them on a long plunging journey inward. These are the long-period comets, the ones that appear in our skies with no prior warning, following orbits so elongated that their last visit may have been millions of years ago, or may never have happened before at all. They fall inward from the Oort Cloud round the Sun, develop their tails as solar radiation and wind drive off their surface material, blaze briefly in the inner solar system's sky, and then, if they survive, if they are not captured into a shorter orbit by Jupiter's gravity, or broken apart by tidal forces, they recede back into the outer dark and do not return for another age. The Oort Cloud is so far away that the Sun, from its outer edge, is not obviously different from other stars. It is the brightest star, yes, still clearly dominant, but it is a point source, a star among stars, and the planets of the inner solar system are invisible, lost in its glare. From the Oort Cloud, the solar system as a system is not visible, it is just a star. This is the perspective that distance ultimately offers. The solar system that contains everything we have ever known, everything we have ever been, every planet we have visited, every spacecraft we have launched, every telescope we have pointed outward. From far enough away it is simply a star, unremarkable in catalogue, ordinary in spectral type, one of approximately 300 billion in this galaxy alone. And yet from inside it, from the vantage point of Earth, it contains Saturn with its rings and Enceladus with its plumes, and Titan with its orange haze and Pluto with its heart-shaped glacier. It contains Jupiter's 400-year storm and Neptune's winds, the fastest sustained winds in the solar system at over 2,000 kilometers per hour. It contains the asteroid belt and the Kuiper belt and the Oort Cloud and all the space between them, all the dark and cold and all the quiet processes running in that dark and cold without witness. It contains, somewhere near one of its outer arms, a small rocky planet with liquid water on its surface and a thick oxygen-nitrogen atmosphere, and a moon large enough to cause tides and life, improbable, persistent, inventive life, that has spent a few thousand years developing the tools to look outward and understand partially what it sees. That understanding is not complete. It may never be complete. The universe is under no obligation to be fully comprehensible to the creatures it has accidentally produced. But the understanding grows, instruments improve, missions are planned and launched and arrive and transmit, data accumulates, models are revised, questions sharpen, and slowly, across centuries, the picture becomes clearer. Not simpler, never simpler, always more complex and more strange and more full of things that should not exist but do. The next large space telescope, the ones being designed now, will see further than anything before them. They will examine the atmospheres of planets orbiting other stars, looking for the chemical signatures of processes that might indicate biological activity. Oxygen, methane, water vapor, in combinations that chemistry alone cannot easily produce. They will not find certainty. They will find data. They will find more questions. And the questions will be better questions than the ones we're asking now. And that is how it always goes. From here, from this distance, the galaxy itself becomes visible as a structure. The Milky Way, which from Earth appears as a band of diffuse light across the sky, dense with unresolved stars, is, from outside, a spiral. A barred spiral galaxy, specifically, with a central bar of stars from which two major spiral arms extend, curving outward and several minor arms threading between them. The Sun sits in one of those arms, the Orion arm, roughly 26,000 light-years from the galactic centre, in an unremarkable position in the disk, orbiting the centre at a speed of roughly 220 kilometers per second, and completing one full orbit every 225 million years. One galactic year. The Sun has completed about 20 of them since it formed. In the first galactic year of the Sun's existence, the solar system was still forming. In the most recent galactic year, the entire history of complex animal life on Earth unfolded, from the Cambrian explosion to now, from the first hard-shelled creatures in shallow seas to the species lying in the dark tonight thinking about rings of ice around a distant planet. One galactic year. The whole story of everything with eyes and bones and the capacity to wonder, compressed into a single orbit of the Sun around the centre of the Milky Way. The galactic centre is not a peaceful place. At its heart sits a supermassive black hole, Sagittarius a star, 4 million times the mass of the Sun, compact enough to fit within the orbit of Mercury. Around it, stars orbit at speeds and in configurations that would be impossible anywhere else in the galaxy. Some completing full orbits in just a few years, moving at thousands of kilometers per second in tight ellipses around the invisible central mass. These stars are the evidence. Their orbits trace the shape of the gravity well. The black hole itself emits no light, but its influence on everything around it is unmistakable, precise, measurable. Occasionally Sagittarius A star feeds. Material falls in, gas, dust, sometimes entire stars torn apart by tidal forces at the edge of the event horizon, and the infalling material heats up as it spirals inward, releasing enormous amounts of energy in the form of X-rays and radio waves and visible light. These flares are brief by galactic standards, lasting hours or days, but they illuminate the galactic centre in wavelengths that observatories on Earth and in orbit can detect. The Event Horizon Telescope, a network of radio telescopes distributed across the Earth, functioning together as a single instrument the size of the planet, imaged Sagittarius A star in 2022. The image showed a ring of hot glowing material surrounding a dark central shadow. The shadow of the event horizon, the edge of the point of no return, photographed for the first time in the history of observation, a ring of light around an absence, a portrait of something that cannot be directly seen, described by everything surrounding it. There is a parallel there, if you want one. The things we cannot directly observe are often best understood by what surrounds them, by the shape of their influence, by the orbits and behaviours they induce in everything nearby. The black hole is known by the orbits of stars. The subsurface ocean of Enceladus is known by the chemistry of its plumes. The origin of Saturn's rings is known by the age and composition of the ring material. The most important things are often the ones that can only be approached indirectly, through careful reading of their effects on everything else. The universe teaches this lesson everywhere you look, and it is not a discouraging lesson. It is in its way an encouraging one, because it means that the absence of direct observation is not the end of understanding. It means that careful attention to what is present can reveal what is hidden. It means that nothing is entirely beyond knowing, given enough patience and enough ingenuity and enough willingness to read the signals that arrive indirectly, bent by distance and time, diminished, but still carrying information, still telling something to whoever has the instruments and the attention to receive it. The light from Sagittarius, a star, takes 26,000 years to reach Earth. The light you are receiving right now from the night sky left its sources at different moments in history. Some stars showing you what they looked like a few years ago, others showing you what they looked like before agriculture existed, others showing you light that left them before Homo sapiens walked the Earth. The night sky is not a single moment. It is a layered archive, every point of light a different page from a different era, all arriving simultaneously, all hitting the retina at once, assembling in the mind into the illusion of a unified present. You're looking at many different pasts at once whenever you look up, and from all those different pasts, across all that distance, across all those different moments in the history of the galaxy, the light still arrives, diminished, patient, carrying information, reaching a small warm planet where something lies in the dark and receives it and tries to understand what it means. Understanding is not a destination, it is a direction. You do not arrive at it, you move toward it, and the moving is the thing, and the thing never ends, and that is not a failure of understanding but the nature of it. Every answer is a vector, pointing somewhere new. Every confirmed fact opens onto a wider field of unconfirmed ones. Every mission that returns data generates more questions than it resolves, and the scientists who built the mission know this before they launch it and launch it anyway, because the questions that come after are better questions than the ones they started with, and better questions are the whole point. The galaxy is very large, 250,000 light-years across, roughly from edge to edge, containing somewhere between 100 and 400 billion stars. The uncertainty in that number is itself a measure of how large the galaxy is, that the count cannot be pinned down more precisely than a range of 300 billion. Each of those stars its own sun, many of them with planets, some of those planets in the temperature range where liquid water could exist on a surface, some of those with atmospheres, some of those atmospheres containing the right chemistry, some of that chemistry, perhaps, doing something. The Drake equation attempts to estimate the number of communicating civilizations in the galaxy. It is less a calculation than a framework for organizing ignorance, each term in the equation representing something we do not yet know well enough to confidently quantify. The rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, the fraction where life actually develops, the fraction where life develops intelligence, the fraction of intelligent species that develop detectable technology, the length of time such civilizations remain detectable. Multiply them all together and you get a number that ranges, depending on your assumptions, from less than 1 to millions. We do not know which end of that range is closer to correct. We have not yet detected a signal. We have not yet found biology on another world. We have found chemistry, organic molecules in space, amino acids in meteorites, the building blocks of the building blocks everywhere, but not life itself, not yet, not confirmed. The search continues. The instruments improve, the sensitivity increases, and the silence so far is not conclusive. The galaxy is very large, and we have been listening carefully for only a few decades with instruments that, by the standards of what will exist in a century, are primitive. The silence may mean we are alone, or it may mean we have not yet asked the question loudly enough or in the right frequency or toward the right part of the sky. Or it may mean that the civilizations that exist are not communicating in ways we have thought to look for. Or it may mean that the distances are simply too great and the signals too diluted by the time they travel from there to here. The silence is data, but it is not yet a conclusion. There is a thought experiment sometimes called the Fermi paradox, named for the physicist Enrico Fermi, who reportedly asked during a casual lunch conversation simply, "Where is everybody?" If intelligent life is not vanishingly rare, and if civilizations tend to expand and explore as ours has begun to do, then the galaxy should by now be full of signs of intelligence, artifacts, signals, structures visible across interstellar distances. And yet, we see nothing. The stars are quiet. The signals we receive are natural. Pulsars, quasars, the cosmic microwave background, the ordinary radio noise of a galaxy going about its business. Nothing artificial, nothing arranged. Where is everybody? The question sits at the center of the search for extraterrestrial intelligence, like the shadow at the center of the event horizon. Telescope's image of Sagittarius, a star, defined by what surrounds it, made visible by the absence at its heart. We know the question is real. We do not yet know the answer, and perhaps that is appropriate. Perhaps the grandest questions are the ones that a single human life is not long enough to resolve, that a single civilization may not be old enough to answer, that require a patience measured not in years or decades, but in the same units the universe uses. Millions of years, galactic orbits, the slow accumulation of observation across timescales that dwarf everything familiar. The universe has been asking and answering its own questions for 13.8 billion years. The questions it is working on now, the nature of dark matter, the origin of dark energy, the question of whether life exists elsewhere, the question of what happened before the Big Bang, if before is even a meaningful concept. And these are questions that may take longer to answer than the current age of the universe, or they may be answered next century. The history of science is full of both. Questions that seemed permanently beyond reach and were resolved in a generation, and questions that seemed almost answered and turned out to contain depths that swallowed entire fields of inquiry for centuries. You cannot know which kind a given question is until it is answered. And so you keep asking. You keep building instruments and launching spacecraft and pointing telescopes and analysing data and writing papers and arguing about interpretations and revising models and beginning again. You keep going. Because the alternative, stopping, deciding the questions are too hard or too large or too unlikely to be resolved in a useful time frame, is not something that the curious mind can actually do. Not really. Not permanently. Curiosity is not a choice. It is a condition. And it is the condition that brought us here tonight, from Saturn's rings, which were the beginning, through the shepherd moons and the hexagonal storm and the plumes of Enceladus, through Titan's orange methane haze and Pluto's glacial heart, through the Kuiper belt and the Oort Cloud and the galactic centre, and the image of a black hole described by the ring of light around its shadow, all of it connected, all of it part of the same expanding journey outward from a small warm planet where something lies in the dark and cannot stop wondering. The wondering is the story. The wondering has always been the story. From the first human who looked up at Saturn and noticed it moved differently than the stars around it, moved and kept moving night after night, tracing a slow path against the fixed background of the constellations, to Galileo squinting at those blurred flanking shapes through his imperfect lens, to Huygens resolving the rings, to Maxwell proving their composition mathematically, to Voyager photographing the shepherd moons and the spokes, to Cassini spending 13 years in orbit and then becoming part of the planet it had studied. It is all one continuous act of attention. One long looking, One sustained refusal to stop asking what is there and how does it work and what does it mean. The rings were there before anyone asked. They will be there, in some form, long after the asking has moved on to other questions. They do not require our attention to exist, but they reward it. Everything out here rewards attention. The more carefully you look, the more there is to see, and the more you see, the more clearly you understand how much remains unseen, and that understanding, that precise calibration of what is known against what is not, is what science actually is. Not a collection of facts, a living relationship with the boundary between the known and the unknown, always moving, always finding the boundary further out than it was before. The boundary is very far out tonight. Out past where Cassini went. Out past where New Horizons is still travelling, now beyond the heliopause. The boundary where the solar wind gives way to the interstellar medium, where the sun's direct influence ends and the galaxy's ambient environment begins. New Horizons crossed that boundary and kept going. It is the 5th spacecraft to enter interstellar space, following the 2 Voyagers and the 2 Pioneers, all of them still moving outward at tens of thousands of kilometers per hour, all of them carrying gold-plated records or plaques inscribed with information about the civilization that built them. Messages in a bottle thrown into an ocean so large that the odds of anyone finding them are functionally zero, and yet someone made them anyway, engraved them carefully, attached them to the spacecraft with care. Because the gesture mattered even without an audience. Because sending something beautiful into the dark is worth doing regardless of whether it is ever received. Voyager 1 is currently more than 23 billion kilometers from the Sun. It has been travelling since 1977. It is still transmitting. The signal it sends back is so weak by the time it crosses that distance that it arrives at Earth with less power than a refrigerator light, and yet the giant dish antennas of the Deep Space Network can hear it, can decode it, can extract science from it. The signal crosses 23 billion kilometers and arrives and is understood. That is not a small thing. That is one of the most remarkable achievements in the history of the species. A machine launched nearly 50 years ago, still working, still in contact, sending information back across a distance that takes light over 20 hours to cross, and we are still listening, still receiving, still learning from it. Voyager 1 carries a golden record. On it, encoded in a format designed to be decodable by any sufficiently advanced intelligence that might find it, though the odds are vanishingly small, are sounds and images from Earth, music from many cultures, greetings in 55 languages, the sound of wind and rain and surf, a mother's first words to a newborn child, the brainwave patterns of a young woman thinking about her life and her hopes, the pulsar map that shows where the Sun is located in the galaxy, so that if anyone ever finds it and wants to know where it came from, they can find their way back. The record includes, among its images, a picture of the night sky. Stars, the same stars that are outside tonight, above the clouds, above the atmosphere, fixed and ancient and patient. The record is out there now, past Neptune, past the Kuiper Belt, past the heliopause, moving through the interstellar medium at 17 kilometers per second, carrying a picture of the sky that was taken from Earth, moving through the sky that picture depicts, further and further from the point of origin, into the dark between the stars. The nearest star system to the Sun is Alpha Centauri, roughly 4¼ light-years away. At Voyager's current speed, it would take approximately 70,000 years to reach it, though Voyager is not headed in that direction. In 70,000 years, Voyager 1 will be nowhere near any star. It will be in the middle of the vast empty dark between stellar systems, where the nearest light source in any direction is years away at the speed of light, where the Sun is just another star in a field of stars, where nothing marks the position of Earth or the existence of the civilization that built and launched this small golden record-carrying spacecraft, except the spacecraft itself, still moving, probably still intact, because space is empty and there is very little to damage it, just moving and moving and moving 17 kilometers per second, forever. Or something close enough to forever that the difference does not matter. The universe is 13.8 billion years old. It began, as far as we can determine, using the best physics available, in a state of extraordinary density and temperature, everything that now exists compressed into a volume smaller than a proton, and then expanding, not exploding into pre-existing space, expanding, space itself stretching, carrying matter with it, cooling as it expanded, the first particles forming, then the first atoms, hydrogen and helium, then the first clouds of gas collapsing under gravity into the first stars, burning briefly and brilliantly and ending in supernovae that scattered heavier elements into the surrounding gas. Elements that had been forged in stellar cores under conditions of pressure and temperature that no laboratory on Earth can replicate. Carbon, oxygen, nitrogen, iron, silicon. All the elements that planets and moons and living things are made of, scattered into space and gathered again into new clouds and new stars and new solar systems. The calcium in your bones was made in a star. The iron in your blood was made in a star. The oxygen you are breathing right now, the nitrogen that makes up most of the air in the room, the carbon in every molecule of every cell in your body, all of it forged in stellar cores billions of years ago and scattered by stellar deaths and gathered by gravity and built by chemistry into you. You're made of star material. This is not a metaphor. It is nuclear physics. The atoms in your body were inside stars before they were inside you, and before they were inside stars they were drifting in the cold gas clouds of the early galaxy. And before that, they were in the first few minutes of the universe itself, forming from the raw energy of an expansion that began 13.8 billion years ago. The universe made you out of itself. It used its own material, the same material that makes Saturn and its rings and Enceladus and Titan and Pluto, and the Oort Cloud and the Milky Way's spiral arms and the shadow at the centre of Sagittarius a star. All of it the same material in different arrangements, at different scales, under different conditions, doing different things. The universe is one thing that has arranged itself into an extraordinary variety of other things, and among those arrangements is something that can look back at the universe and recognise it, partially, and find it beautiful. That is what is happening tonight. The universe arranged into a person, lying in the dark thinking about the universe. The thing looking and the thing being looked at made of the same ancient stellar material, briefly organised into this, into attention, into wonder, into the particular kind of consciousness that lies awake in the small hours and thinks about rings of ice and hidden oceans and the long journey of a signal across 23 billion kilometres and arrives, not at an answer, but at something quieter and more lasting, a sense of belonging to it, not belonging in the sense of ownership or centrality, not the old idea that the cosmos was made for human beings, arranged around human purposes, scaled to human concerns. The cosmos was not made for us. It preceded us by billions of years and will continue after us by billions more, and it does not organise itself around our timescales, or our needs, or our questions. But we are in it. We are of it. We are, in the most literal chemical sense, continuous with it. Built from it, sustained by it, returned to it eventually, recycled as everything is recycled, the atoms moving on to other arrangements after the current arrangement concludes. That continuity is not a small comfort. It is a very large one, if you let it be. The feeling of being a temporary arrangement of ancient material in an enormous ongoing universe, not lost in it, not insignificant within it, but genuinely part of it, the same stuff, the same story, just a different chapter. The story started with hydrogen. With the simplest atom, one proton and one electron, forming in the cooling aftermath of the Big Bang. From hydrogen, stars. From stars, heavier elements. From heavier elements, planets. From planets, chemistry. From chemistry, something stranger, something that asks questions, something that sends spacecraft into the dark with golden records attached, something that builds telescopes to image the shadows of black holes and points instruments at plumes of water vapour rising from moons of Saturn to ask whether something lives inside. From hydrogen, eventually, the question, where is everybody? From hydrogen, eventually, tonight. The story does not have an ending that has been written yet. It is still going. It was going before you were born, and it will be going after, and in the meantime you are in it. You are part of it. The same ancient material moving through the same ancient universe, lying in the dark on a small warm planet, while Saturn turns in the outer solar system, and its rings catch the last of the sun's diminished light, and a spacecraft launched nearly 50 years ago carries a golden record through the interstellar dark at 17 kilometers per second, moving away from everything that made it, still going, still carrying its cargo of music and greetings and the sound of a rain, and a mother's first words to her child, out into the quiet between the stars where the only thing that moves for billions of kilometers in any direction is that small golden record-carrying machine and The light from distant suns and you, breathing, drifting now toward the edge of something. Not an edge you fall from, but an edge you cross without noticing. The way night crosses into sleep. The way one thought dissolves into the next, and the next grows softer, and the distances increase and the details blur, and the vast patient dark of the universe wraps around everything. And the last clear thing is that it is still going. All of it still going. The ring still turning, the signal still travelling, the question still opening onto more questions, the story still moving forward through the dark. The rings are still turning. This is the first thing and the last thing and the truest thing about Saturn, that it does not stop. That the motion which began 4.5 billion years ago in a collapsing cloud of gas and dust has not paused once, not for a moment, not for any reason, and will not pause tonight. The ice particles complete their orbits. The shepherd moons nudge and herd. The spokes form and dissolve. The hexagon persists at the North Pole, six-sided and patient, running its standing wave through the clouds of a planet that has never known stillness. There is something in that continuity that the mind can rest against. Not the frantic continuity of things that must keep moving to survive. Not the continuity of a heart that stops and ends everything. Not the continuity of breath that must be maintained or lost. The continuity of orbits is different. It is structural. It is the kind of motion that requires no effort, no maintenance, no will. A particle in Saturn's B-ring does not choose to keep orbiting. It simply does, because the forces acting on it, gravity pulling inward, velocity carrying it forward, are in a balance so precise that the orbit maintains itself indefinitely, without intervention, without attention, without anyone watching. Most of the universe runs this way, on its own, without supervision. The stars burn through their fuel on schedules set by the physics of their mass. The galaxies rotate on timescales measured in hundreds of millions of years. The universe expands, and the expansion accelerates, driven by whatever dark energy is. And we do not know what it is, only that it is there, measurable in the recession of distant galaxies, a force that is doing the largest work in the cosmos, without any name we fully understand, the largest work, running without a name. In the dark between the galaxies, in the spaces so vast that the nearest neighbour is millions of light years away, in the voids where almost nothing exists, not stars, not gas, barely even the sparse hydrogen of intergalactic space, just the geometry of space-time itself stretching, the distance between things increasing not because the things are moving through space, but because space itself is growing, the fabric of the universe gently expanding in all directions simultaneously, carrying everything with it, including Saturn, including its rings, including the small warm planet where you are. Everything is moving away from everything else, slowly, on the largest scales. The universe is not collapsing inward. It is not static. It is opening. Has been opening since the first fraction of a second after the Big Bang, and the rate of opening is increasing. And where that leads, whether the expansion continues forever, whether the universe eventually grows so large and so cold that all the stars burn out and all the black holes evaporate, and there is nothing left but an infinite cold dark dotted with the last fading particles. That is called the heat death, the final equilibrium, the universe at maximum entropy, everything at the same temperature, no gradients left to drive any process, no energy available to do any work. But that is so far in the future that the number of years required to express it makes the current age of the universe look like the first second of a day. We are early. Cosmically, we are at the very beginning. The universe is 13.8 billion years old, and it will last in some form for something like 10 to the power of 100 years. 10 with 100 zeros after it. The current age of the universe, written in years, is a 14-digit number. The eventual age of the universe at heat death is a number with 100 digits. We are nowhere near the middle. We are in the prologue. The stars being born right now will live and die, and their material will be gathered into new stars, and those stars will live and die, and the process will continue for so long that everything familiar about the current universe, the spiral galaxies, the star-forming nebulae, the planetary systems with their rings and moons and hidden oceans, will eventually be succeeded by configurations of matter and energy that we cannot currently predict or imagine, because the physics operating at those timescales may involve processes that have not yet had enough time to become significant. The universe is still becoming something. It does not know what. It is working it out as it goes. the way all the best stories do, and the story so far is extraordinary. From hydrogen to helium to carbon to planets to oceans to chemistry, to something that wonders about all of this, in 13.8 billion years, which is simultaneously an unimaginable length of time and a tiny fraction of the story's total duration. The universe has been at this for less than 2% of the time it will have, if current models are correct. Everything we know, every star we have named, every planet we have visited, every civilization that has ever existed anywhere in the galaxy. All of it happening in the first 2%. What comes next is not knowable from here. The instruments do not reach that far. The models do not extend reliably to those timescales. But the direction is clear. The universe continues. It expands. It cools. It generates structure wherever the conditions allow. It runs its processes in the dark, without witness, without intention, without anything that resembles a plan. And occasionally, in the right conditions, on the right kind of planet at the right distance from the right kind of star, it generates something that looks back at it and tries to understand. That looking back is rare, perhaps vanishingly rare, perhaps common beyond our current ability to detect. We do not yet know. But it is real. It is happening right now, on this planet, in this room, in the mind that has travelled tonight from Saturn's rings to Enceladus, to Titan, to Pluto, to the Oort Cloud, to the galactic centre, to Voyager's golden record to the heat, death of the universe and back again, and has not once felt that the journey was too long, or the distances too great, or the questions too unanswerable to be worth the asking. That is what curiosity is, the refusal to find the universe too large, the insistence on looking anyway, even knowing you will not see everything, even knowing the answers will generate more questions, even knowing that the story is longer than any one life can contain. You look because the looking is its own reward, because every genuine glimpse of what is actually out there is worth more than any amount of comfortable not knowing, because the universe is real, and it is extraordinary, and you are in it, and that means something even if it does not mean what we once assumed it meant. The rings of Saturn are real. The hidden ocean of Enceladus is real. The golden record moving through the interstellar dark at 17 kilometers per second is real, right now, in this same moment, carrying the sound of rain and a mother's first words to her child through a silence so complete and so vast that the silence itself becomes a kind of presence. And you are real, made of the same ancient stellar material as everything else, temporarily arranged into a person, in a room, in the dark at the end of a day, at the beginning of sleep, with a mind that has just travelled from here to the outer solar system and back, from the composition of ring ice to the heat death of the universe, from the shepherd moons of Saturn to the first hydrogen atoms of the Big Bang. That is not a small thing to have done. That is the universe looking at itself through a temporary arrangement of its own material and finding it remarkable. The journey does not require a destination to have been worth taking. The rings were worth visiting even though you had to leave. Enceladus was worth knowing about even though you cannot go there. The golden record was worth thinking about even though neither you nor anyone you will ever know will live to hear whether it is ever found. The questions about life elsewhere were worth asking even though no answer has come yet and may not come in your lifetime. The heat death was worth contemplating even though it is so remote in time as to be effectively fictional. All of it worth it. Because the mind that can travel these distances, even in imagination, even lying in the dark at the end of an ordinary day, is doing something that almost nothing else in the known universe can do. It is making meaning from physics. It is finding beauty in orbital mechanics. It is feeling something, some unnamed thing between awe and belonging and smallness and connection, while thinking about ice particles circling a gas giant 1.5 billion kilometers away. The unnamed thing is real. It may be the most important thing. The room is quiet. The distance outside is enormous. The rings are turning without you. They were turning before this began, and they are turning now, and they will be turning long after this particular night has dissolved into the larger story of things. Saturn is in the outer solar system right now. Its North Pole hexagon is persisting. Enceladus is venting. Titan's methane rain is falling through orange haze onto a surface that has never been touched. Voyager is moving through the interstellar dark. The universe is expanding in all directions simultaneously. The questions are still open. Everything is still going. The stars that are outside tonight have been burning for millions or billions of years and will continue burning after every concern of this particular evening has long since resolved or dissolved or been replaced by other concerns that will in turn resolve or dissolve. The light coming through whatever gap exists between the curtains travelled years or centuries to arrive at this room tonight, and it arrived, and it is here, the same as you are here, briefly, in the dark, in the quiet, at the end of the long day and the long journey. The ice is old, the orbits are stable, the signals are still travelling. There is more universe than one night can hold, and it will be there tomorrow, all of it, unchanged in any way that matters. The rings still catching that ancient diminished light, the questions still open, the dark still full of things worth finding. Tonight you have gone far enough. Tomorrow night the dark will be waiting, and there is so much more of it left to explore.